Hello there, this is Miss Page. Welcome. In this lesson, we are going to talk about how to use our skills of factoring and quadratic formula and all of our quadratic strategies to find all of the complex zeros of a polynomial function. So this will include all of our real zeros and our imaginary zeros. And so one of the skills that we'll use is factoring of higher degree polynomials, such as factoring a sum or difference of two cubes. So here we have a difference of two cubes. So remember that they will factor into a binomial times a trinomial, and that we use the quantities that are being cubed in our factors. And we also use, remember, the word SOAP to help us make sure our signs are correct. So S means we use the same sign as our binomial. Then we use the opposite sign, which would be a plus here. And then AP means our last sign is always plus or always positive. And in our trinomial, our first term is our first quantity in parentheses squared. Our middle term, remember, is the product of the two quantities in the parentheses. And then our last term in our trinomial is that second quantity in the parentheses squared. And then simplified here to x squared plus 2x plus 4. And then we have our binomial factor of x minus 2. So that's one of the skills that we will be using here. Another thing that you want to keep in mind is how many total complex zeros you should have in your final answer to make sure that you haven't lost any or somehow made a mistake somewhere. So the fundamental theorem of algebra is what tells us this, that the degree of our function, which is the highest power of our variable of x, is going to tell us the total number of zeros or roots in this case. So roots is a word that we may not have really focused on before. Root is a word that also is synonymous with zero. So when we're finding roots, it's the same process as finding zeros. So for our cubics, we would expect there to be 3 roots or zeros. For our quartics, which has a degree of 4, we would expect there to be 4 roots or 4 zeros. Another thing that we have to keep in mind too that helps us with making sure that we haven't made any mistakes is our complex conjugate root theorem. And so if we have irrational roots or imaginary roots, they come in pairs, specifically conjugate pairs. So if we have a 3 plus root 2, we also have a 3 minus root 2. If we have a negative 1 minus 3i, we also have a negative 1 plus 3i. If we have a negative square root of 5, we also have a positive square root of 5. If we have a positive 2i, we also have a negative 2i. So irrational and imaginary roots or zeros always come in conjugate pairs. And that comes from that plus minus that we do with our square root property, or the plus minus that we also have in our quadratic formula, where we have negative b plus or minus b squared minus 4ac all over 2a. All right, so let's take a look at a problem. So for each of these polynomial functions, we are going to find all the complex zeros, include multiplicity, so we can write those more than once. We need to identify each of our zeros as rational, irrational, or imaginary. And we want to write all of our zeros in simplest form. All right, here we go. So we are looking for zeros, which means that we're solving for values of x when our function value is 0. This uses, again, factoring skills we learned earlier. So there's the GCF is 1. We have a trinomial structure. And we have a quadratic structure where we would use factors of x to the 4th of x squared and x squared because that's our middle power of x. We need 2 factors of 32 that'll give us a negative 18, which would be a negative 16 and a negative 2. And we could actually pause here. Once we get the factoring down to x squared or smaller, then we can go to our zero product property. And so you could factor x squared minus 16 further if you wanted to, but you can't do that with x squared minus 2. So it's up to you if you stop now or if you factor further. Zero product property says either x squared minus 16 equals 0 or x squared minus 2 equals 0. And here we get x squared equals 16, and we take our square root of both sides. Remember that plus or minus. And we get zeros of -4 and +4. Here we're looking at x squared equals 2. So the square root property gives us plus or minus the square root of 2, which cannot be simplified. Now, if we write these from least to greatest, we should realize that -4 would be our smallest zero, and then our negative square root of 2, and then our positive square root of 2, and then our +4 is our largest, and we have no multiplicity this time. So that finishes that problem. All right, let's take a look at another one. So again, process is basically the same. If we want to find our zeros, we know that our function is equal to 0. Keep your critical thinking hat on, meaning that don't make assumptions about what to expect. Always examine and do an analysis. So for example, here, this is x to the 4th like our previous example, but it's not the same type of factoring because this time we have a common factor, a GCF, of x squared. And what we need to recognize here is that we cannot factor this into two binomials because 5 is prime. The only factors of +5 that we could use here would be a -5 and a -1, and that gives us a -6x middle term, not a -3x. So that means that we can't factor any further. And so either x squared equals 0 or x squared minus 3x plus 5 equals 0. Here we get x equals plus or minus the square root of 0. Now, there technically is no positive 0 or negative 0, but this is to remind us that we would get two answers from this because it's x squared, and so we have multiplicity here, 0 and 0 again. On our trinomial here, we have to use our quadratic formula. So a is equal to 1, b is equal to -3, c is equal to 5. And if you don't quite remember your quadratic formula, definitely write it down in your notes. So x equals -1 times b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Plugging in our numbers, we get x equals -1 times -3 plus or minus the square root of -3 squared minus the product of 4, a which is 1, c which is 5, all divided by 2 times a which is 1. And here we're now going to get x equals +3 plus or minus the square root of 9 minus +20, all divided by 2. Be careful, we've talked about this before. This is plus -20, so this is going to be 3 plus or minus the square root of -11 all over 2. We've also talked about the proper way to write zeros of this nature would be to split it apart. So you have your rational part plus or minus, in this case, your imaginary part, because that is the square root of 11 times I, remember. And that would give us then the square root of 11 over 2 times I. So we have our a plus bi form. So going back to our zeros here, we don't want to forget we had our zeros up here and then splitting these apart. So we have here 3 halves minus the square root of 11 over 2 times I. We have 3 halves plus the square root of 11 over 2 times I. And we have 0 and 0. And as I recall, we are supposed to identify our zeros as rational, irrational, or imaginary. So these two are imaginary, so we'll put that with those. And the zeros are, of course, rational. So we can put all that together to conclude. And that does remind me that I kind of forgot to do that part, which I've always warned you guys about. And that's because I know it does happen, even to me. So here what we're looking at with these. So we need to realize here, for identifying purposes, that -4 and 4 are both rational, and -2 and +2 are both irrational. So sorry about that. Okay, so moving on. Let's take a look at this example. So we've got a lot of examples in this particular lesson, just so you know, just to give you more examples of a lot of different types of factoring and when we can use our square root property, when we have to use our quadratic formula, when we don't have to, we can just use basic algebra, that kind of a thing. So in general, though, they're all the same type of problem. The differences become when we get to perhaps usually the solving for x at the end. So here we're looking for zeros. We get x to the 4th minus 16. Here you have to realize that you're not going to be able to add 16 to both sides. You have to factor because you're at x. You have an exponent of 4 right now, so you're not ready to use any strategies other than factoring. So this is a difference of 2 squares. This is x squared minus 4 squared. So remember, we have to use x squared and 4. So we have x squared minus 4 and x squared plus 4. Now we could actually stop our factoring, although we could, if we wanted to, factor x squared minus 4 further, because it's also a difference of 2 squares. We could not do that, remember, with x squared plus 4, because it's a sum, so there's no factoring possible for that one over the set of real numbers. So I'm going to use my zero product property, so x squared minus 4 equals 0, or x squared plus 4 equals 0. This one, adding 4, gives me x squared equals 4. Taking my square root of both sides gives me plus or minus the square root of 4, which gives me x equals -2 or +2. The other one, I'm subtracting 4 from both sides, so I get x squared equals -4. And taking the square root gives me plus or minus the square root of -4. And that is imaginary. That's the square root of 4 times the square root of -1. So that gives me a -2i and a +2i for those values. So no multiplicity here, but I do have -2 and +2, which are rational zeros, and -2i and +2i, which are imaginary zeros. All right, next example. So here we are looking at f of x equals 8x cubed plus 27. So again, to find zeros, the function y values would be 0, and we're solving for x's that create that y value of 0. Here we have to realize that what we have is a sum of 2 cubes, and this would be 2x quantity cubed plus 3 cubed. And remember, this is not the factoring. This helps us because it gives us the 2x and the 3 that are going to create our factors. So we get 0 equals, we have a binomial times a trinomial, And we use SOAP to help us with our signs. So we use the same sign in the binomial as our original binomial of plus. We get 2x plus 3. Then we have our 2x quantity squared, and we use the opposite sign, which would be a minus then, opposite of plus. And then we have our middle term, which is 2x times 3. And then always positive or plus at the end. And then we have our second quantity of 3 squared there. Then simplifying that gives us 2x plus 3. Remember, the 2 is squared along with the x, so that gives us 4x squared minus 2x times 3 is 6x, and 3 squared gives us then a plus 9 at the end. Now, something that I want to remind you about that you might not recall is that this trinomial right here is going to be a prime trinomial, similar to the earlier one that we had with that plus 5 that didn't work for us. So there's no point in trying to factor this further. It will not factor. So we're going to go to our zero product property now. So either 2x plus 3 equals 0, or our 4x squared minus 6x plus 9 equals 0. On the first one, we can use our basic algebra of subtracting 3 and dividing by 2, which gives us negative 3 halves is a 0. But on this trinomial, we then again have to use our quadratic formula. So our a is 4, our b is negative 6, our c is 9, and x would be equal to negative 1 times our b of negative 6, plus or minus the square root of our b of negative 6 squared, minus the product of 4, a which is also 4, and c which is 9, all divided by 2 times a which is 4. Now these are no calculator problems, and so in these situations this value can tend to be kind of large, so I'm going to show you some number sense here that will help us do this more easily without a calculator. So we have a positive 6 here, plus or minus our square root. We've got an 8 for 2 times 4. So let's talk about this. So negative 6 squared is positive 36. And then we have our minus. And then what we have, notice here 4 times 9 is 36. And that 36 is times 4. So this is 4 times another 36. What's important is for you to understand that this 36 is a common factor. And so this is 1 times 36 minus 4 times 36, which means that no matter if we do this all out by hand or using a calculator, 36 is a common factor of that, and 1 minus 4 is negative 3. So this always works out to be negative 3 times that quantity squared right there, which is 36. And that is useful because it allows us to more easily get to this point to where we can start to simplify. So now what we have is 6 plus or minus. This, remember, would be the square root of 36 times the square root of negative 3. And the square root of negative 3 would be the square root of 3 times the square root of negative 1. So that gives us 6 times the square root of 3 times I, all over 8. Splitting this apart so that we can do our simplifying further, we have 6/8 plus or minus 6 root 3 over 8 times I. Now remember that when we have these two rational numbers, so 6 and 8 are both rational numbers, they have a common factor of 2, they can reduce. So this becomes 3/4 plus or minus, this becomes 3 root 3 over 4 times I. And that then is going to give us all of our zeros. So up here, don't want to forget about this one. So we have negative 3/2, which is a rational zero. And then we have 3/4 minus 3 root 3 over 4 times I, and 3/4 plus 3 root 3 over 4 times I. And those are both imaginary because of the I. All right, so let's take a look at what's next. All right, let's take a look at this one. So here we have our function. To find our zeros, we know zeros equal to x cubed plus 5x. This time, this is not a sum of two cubes because x is a common factor. And we factor that out, we get x squared plus 5. And so here is all the factoring we can do. Zero product property says either x equals 0 or x squared plus 5 equals 0. For this one, the second one here, to continue to solve, we would subtract 5, square root of both sides. We get the square root of x squared equals plus or minus the square root of negative 5. That is going to give us x equals, this of course is the square root of 5 times the square root of negative 1. That's plus or minus the square root of 5 times I. So for our zeros, we have 0, which is rational. We have our negative square root of 5i and our positive square root of 5i, which are both imaginary. So again, don't make assumptions. Always analyze the structure of the polynomial you're working with for what type of factoring is appropriate. All right, this is going to be our final example here. So here we're looking at a 4-term polynomial. So when we go to find our zeros, we have 0 equals x to the 4th minus 6x cubed minus 17x squared plus 102x. So you might think we're going to jump into grouping, but we're not quite going to jump into grouping because this time we actually have a GCF of all 4 terms of x. So what I'm going to do first is factor out x. Sorry, this should be a squared. And I'm going to use grouping now only on this part here. So the first two have a GCF of x squared. And we can expect for the second two, the GCF to be this negative 17. So that we'll get an x minus 6 here. We can always double check, of course, take 17 times 6 and make sure it does give us 102, which it does. And then the second part of the grouping, x minus 6 is a common factor here, times x squared minus 17. Don't forget to bring down your x. All right, so we can stop our factoring there because all of our factors are to the first power of x or the second power of x. So zero product property now says either x is 0, x minus 6 is 0, or x squared minus 17 is 0. And this one is done. This one will give us a 6. And this one, we have a little bit more work to do. Adding 17, we get x squared equals 17. Taking the square root of both sides, we get plus or minus the square root of 17. And 17's prime, so that's not going to simplify. So we get, that is our simplest form of our answers. So for our conclusion about all of our zeros, these zeros of 0 and 6 are both rational. So we've got 0 and 6, which are rational zeros. And positive and negative square root of 17 are irrational zeros. Like so. All right. So before we get into the practice problems, I really kind of want to, at this point, kind of go over that quadratic formula with from a sum or a difference of two cubes a little bit more thoroughly. So the idea is if I have a function where I have a sum or difference of cubes, so let's say that I have 27x cubed minus 8, all right? And the factoring that I would get there would be 3x minus 2, and I'd get here a 9x squared minus 6x plus 4. This trinomial right here is going to be a prime trinomial, meaning it won't factor any further. So when I go to solve for x, I'm going to have that 9x squared minus 6x plus 4 equals 0. I'm going to have to use my quadratic formula. So I'm going to get x equals 6 plus or minus the square root of that negative 6 squared minus 4 times a, which is 9, times c, which is 4, all over 2 times a, which is 9. So the math without a calculator for this, which came from -1 times -6, which I simplified in this, pretty straightforward. You'll be able to do that, no problem. This, it's easiest if you remember that that's going to be the square root of a -3 times whatever your quantity squared gives you, like so. And the reason it's going to always be that is because this structure right here simplifies to that number times a -3. So this is a 1 times a 36. And this is a 4. So minus 4 times 9 times 4, which is 36. 36 is a common factor. And that leaves us with 1 minus 4. And 1 minus 4 is -3. If I take, looking at another one here with different numbers, let's say our function f of x is equal to x cubed minus 216. Do I want to do that one? Nah, that'll give us 6's again. Let me do 343. So 343 is 7 cubed. So this would give us as factored form x minus 7. And then we'd have an x squared minus 7x plus 49. So to solve for zeros, we'd have to use our quadratic formula here. And this then would give us x equals -1 times -7 plus or minus the square root of -7 squared minus 4 times a, which is 1, times c, which is 49, all over 2 times a, which is 1. This is going to be a 7. This is going to be a 2. What I'm saying here is that this is going to be -3 times 49. This part right here is 1 times 49. This part right here is a -4 times 49. 49 is a common factor, and that leaves us with 1 minus 4, and 1 minus 4 is -3. And that then is what I'm putting inside there. And that's from a sum or difference of cubes to its factored form and using the quadratic formula. That's actually always the pattern that you get. It's its structure. All right, so here is first practice problem. Pause your video, give this one a try. All right, let's take a look at the answer. All right, hopefully you are in agreement. Let's try another one. All right, I'm going to reveal the answer now. This one, hopefully you realize you had a difference of two squares and that you used x squared in the first spot. You know, some people have had a little trouble with that in the past. And both of these, that's as far as they factor, so then you have to use your square root property, giving you two irrational zeros and two imaginary zeros. Let's try another one. All right, pause here. All right, this is one of those some difference of cubes problems, so I hope that you did all right on this one. This is what I was talking about. This right here is a prime trinomial, and so we have to use our quadratic formula on it. This structure right here will turn out to be -3 times 16, since 4 squared is equal to 16. And so this is showing it as -48 because the math isn't too hard, but it will be 1 times 16 minus 4 times 16, and that would be 16 times 1 minus 4. That would be 16 times a -3, and that's the square root, and that's the square root of 16 times the square root of 3 times the square root of -1, and that's what's giving this 4 root 3 times your I, and then your denominator, of course, don't lose that, of 2. In this case, it reduces because -4 divided by 2 is -2, and 4 divided by 2 gives us a +2 right there. And then don't forget, of course, you had that rational zero of 4 earlier on. That's another little mistake that I see people do on these problems. All right, let's try another one. Pause here. All right, let's take a look. So this one you also have to use your quadratic formula on because you get this prime trinomial right here, but this one has no pattern. You have to actually do all the math and figure out what is what, because it's not coming from a sum or difference of cubes, it's just coming from a generic trinomial. So you have to use your A, B, and C's, do all the math. It gives you a square root of 40, which then you should simplify to 2 root 10. Again, here you should realize that you can reduce -2 divided by 2 to -1, and then 2 divided by 2 is +1, and 1 times the square root of 10 is just the square root of 10. So it simplifies all the way to the square root of 10. And then don't forget, again, you had that rational zero of 0 earlier on that's easy to forget about. Another practice problem here. Pause. All right, let's take a look. So this one, you have a GCF of x for the whole thing, and then use grouping to factor the x cubed trinomial with 4 terms that's inside the parentheses. So your first pair has an x squared GCF, second pair has a +4. That gives you these, and you still, of course, have your x. So then you have either x equals 0, x plus 3 equals 0, or x squared plus 4 equals 0. And make sure, hopefully, that you simplified this all the way down to positive and -2 times I, like so. All right. Another practice problem, if you would like. Pause here. Let's take a look at the answer. So this one is a factoring by grouping. This time there's no GCF of the entire polynomial, so we can just jump right into factoring by grouping with our 2 pairs. And then working our way down, we have -9, which is rational, and then 2 irrational solutions for a total of 3, which we should get 3 because we have an x cubed. All right, that ends this lesson with all of the practice problems. So have a great day.